the material that we saw before. And now let's just check the first question. Okay. Let's do it. So yeah, and the first question is like, which of the following best describes what an if statement does in Python? And there are 4 options. I decreased time from 1 minute to 30 seconds because I think that 1 minute is like too much. But in case if it's like too fast for you, like I mean 30 seconds, then also just please let me know. And we have like that everyone chose the second option, which is the correct one, that if statement we use it to run a specific block of code only if some condition is true. So that's right, guys. I'm proud of you. So the next question will be about the code that we see here. Let's just check the question. But probably the question is like, what is going to be the output of this code snippet? Yeah. And there are different options. Okay, nice. We have different options, and most of the people chose option B, which is correct. Guys, can someone explain us why you chose B, if you did, and if you don't shy? Guys, please, someone, anyone.
Because we got if condition comparing x with 10 and x equals 3.
Yep.
3 more than 10 is false statement. Therefore, we get, for false statement, we get else code executed, and else code is to print B.
Yep, right. Thank you. So yeah, the basically here we just need like to remember that how we choose the option. If it's true, we go to the left side. If it's false, we go to the right side. And since this is a false, then we go to the right side of the statement. And we just need like to remember the idea of this branching. And since like when you got it, you will be able to like, use it in your code. And I think that this ternary operation, very nice way sometimes to make your code compact and make it more clear. But also, yeah, so it's like in my mind, there are like a lot of things which are like double-edged swords. If you put some like very long statements, it will be very hard to understand what is happening. And in this case, probably the better way is to use regular if-else statements, not a ternary operation. So yeah, just keep it in mind. Now let's go to the next question. And this is so yeah, let's start. So this one is about which statement correctly describes break and continue. And there are 4 options. Okay, here we have that mostly people chose second option, which is correct one. And so basically the idea is that they slightly different. First and one, I mean, like they kind of reversed, but the correct one that continues skips to the next iteration, but break exits the loop entirely. So I think that it's should be pretty clear. Yeah, just like you need to remember that continues like when you need, like, if you want like to go to the next iteration, you're like, okay, let's continue to something. Like in the same way as you're like, for example, talking with someone, if you want like to switch the topic, you're like, okay, let's continue and let's do something else. And if you want like to, for example, interrupt the interaction with the person, you're like, okay, it's like more like as a break here. I don't want to talk with someone. Yeah. And I think that we have last question now. Again, this question about if else branching, pretty similar to the one that we had, but in this case it's not a ternary operation, but multi-line if else statement. And you need just like to select what will be the output. Okay, cool. And in the end, 100% accurate result. So yeah, guys, that's it. This was about quiz. Yeah, thank you for participation. And I'll try to decouple persons in the end. I hope that you used your real names. For me, it will be easier to then to assign it to the table. Yeah. So now let's switch to our topic that we will discuss today. So today we will talk about lists and tuples in Python. And so here usually I start with this example. So let's assume that we want to measure the stress level. I don't know what about you guys, but I am constantly under the stress. And if you know, there are like, for example, some smartwatches and some other devices that help you to track down different vital parameters. For example, you can measure stress level, you can measure like heart rate, right? And why I'm like discussing this thing, it's because usually in this case we want like to have a sequential data. We want like to measure something at one time point, at another, and so on. And in this case, for example, let's assume that we want like to measure the stress level for one day of the person and do it every 5 minutes. And in this case, we can calculate that we will have 288 observations for just one day. And right now we don't have any tools in Python that would allow us to easily collect and store this type of information. And because of that, we will learn a new built-in data type in Python, which is called lists. And basically it's like a list, which means that you have some elements, some items, which are stored in one object, but you have access to the sequence of these elements. And it's like very handy when you want to keep in one place, for example, I don't know, any type of the temporal data. It can be like, for example, stress level is it here. And yeah, so here's just like a visualization that we can measure it. And let's say that you just woke up, your stress level is like super low. You're like, okay, nice day. Then you went to work or like to university. You're like, okay, I feel some tension. I feel some tension. But then something like really bad happened and your stress level is like going to the moon. And now we will just try to use lists in our programs. And to do it, it's very easy. I'll just create a new file. I'll call it like list example. And I want to create a first list. So in this case, I will assign it right away to the variable. Let's call variable stress level. And to create a list, we just need like to use the following syntax. We open square brackets, and inside of square brackets, we can put elements separated by comma, and this will give us the list. So let's put something like that in the same way as you can find it on the web page. That we have sequence, so we measure stress level, and in the beginning it was like 0, 0, then 10, 20, 100, and then it went down 0, 0. So basically this is the first list, we can create it, and after that you can, for example, just print it, check that it works, so Python understands this syntax, we created the list. And also interesting part that in general lists could contain different type of elements. So when in programming lists, it's a specific data structure. If you are like very interested, you can read it in internet, so how the structure is organized. But there are, for example, different type of data structures. If you want like to have a vector of particular type of the data, let's say that you want like to keep just integers, then there is a different way how to store this type of the data when the elements are from the same data type. And usually, just like what I want to mention, that in case if you want like to do some operations over numbers, for example, in a fast way, then lists are not the best option, because lists are slower rather than if you would have numerical vector, for example, for the same task. And because of that, we have some pros and cons. And the positive thing, or like advantage of lists, that we can store different type of the data. I will just put it as a new list, and then you can, for example, specify some string. In this case, it's like ABC string. Then we can put different type of the values, like as an integer, and also we added a float number. And this will work perfectly. So we can run it again, and you see that we have we created the list with different type of the elements inside of it. Okay, now we can create the list. We know how to do it. Just like as an example, you can create, for example, empty list. In this case, I will not assign it to any variable, but you can if you want. And to create an empty list, we just open square and close square brackets, and we don't put any element inside of the brackets. And if we now run it, so you can see that this is an example of the empty list. And also something that I mentioned before, for example, if we try to convert any type of the object to the Boolean data type, let's just try to convert empty list to Boolean data type, and we will see that it's false. As you remember, we discussed it that if objects looks like they're empty or they're like zero, something like that, then when we try to convert it to the Boolean data type, it's a false. But in case if we have some elements inside of the list, at least one, for example, now we have just one element. In this case, when we try to convert it, we will get that it's true. Okay, now we can create lists, and so lists, they contain elements, right? But how can we access different elements inside of the list? To do that, in Python there is a specific syntax which allows us to perform indexing and get the elements by the index. So in this case we will have numbers. So numbers, they go from 10 to 100, right? And now, for example, let's say that we want to get some particular element. And in this case, Python has indexing. It means that for each particular element in the list, we have associated index. And indexing in Python starts from 0. And in this case, you can see, so it's like from 0 to 9. And now, for example, if we are write numbers 3, in this case, numbers, it's a list. And 3, it's particular index. And we can get the access to the element by its index. So in this case, it's 40. And then you can also use some other indexes, for example, numbers of 0, and so on. So these are just like examples. Also there is an example about negative indexing. So Python by default provides also the negative indexing, and it's very useful in some cases. This is how it's organized. So the last element is mapped to the index of -1, and then you go this way, and assign, so we assign like -2 to the second last, -3 to the third last, and so on until like we get to the first element, and we will have like minus length of the list assigned to the first element. Let's just repeat it to kind of memorize it better and to be able to then write our own list. So I'll call it numbers.py, and I'll create numbers in the same way. So something like that. Let's make it up to 100. Now, yeah, so we can write numbers of 0. You can pick up any other number, so for example 2, and then we can try with the negative indexing, for example -2. Let's run it. So when we got that numbers of 0, it's the first element, which is 10. Then we went to the third element, and then -2, we go like backwards, it's 90. Usually also it's a very nice way to discover different things in Python. It's to try, for example, something a little bit off. Let's say that we try to get the value of numbers 100. In our case, we don't have 100 elements or like even 101 element in the list, but we are trying to do it, and we get the error. So error is like index error, list index out of range. And I believe that we will see it like very often during the course, that sometimes when we try to do some indexing or like to get the access to the element, we can like, for example, make an error in our consumption, in our assumption about what is a range of the list, and we can slightly go outside of the range, and then we will get an error. Yeah, also, so what indexing provides us is like the opportunity to change elements inside of the list, and this is a key feature of the list. Also today we will look at the tuples, and there is a one major difference between them, and it's about that one object is mutable and another is immutable. In our case, lists are mutable because we can change elements inside of the list. Let's just copy paste this example. I will just paste it here, and I will remove all these statements. Let's just run it. And in this case, what we are doing, we want like to change the value of the first element. It was 10, and then by using the reassignment, we're saying that okay, now numbers 0 is -100, and then my numbers of -1 is 0, so which is this element. Let's just run it, and you can see that after this operation we indeed changed the list, and we have now -100 as the first element, and as the last element we have 0. Also here I want like just to say that for example, in reality you can use indexing with lists in place in terms of that you, for example, if you don't assign them to the variable, so sometimes you can do it, I believe. Let's say that we have a list, and then you can use indexing right after the list. So in this case, we specified the list, and now the second pair of brackets, it's indexing. So we just like saying, okay, I want like to get the first element of this list, just like to show you that you can do it. Okay, now I want to talk about slicing. So slicing, basically, it's a way to get a subset of the list. Super useful operation in my mind, because during the some data analysis or something like that, usually you do it a lot. You get some like slices, and the name explains itself. So you can think that you have a like your object, and then you just like slice some parts of it. And this is a syntax for the slicing. we have here the list object. It can be a variable name or it can be like a real list, just like, for example, that was just declared. And then the syntax is like, in a way, how it works similar to the range function. But how it looks like, so we can specify 3 values inside of the square bracket. So you can think about it, it's like in the same way as the indexing, but now we provide not just one element, but 3 elements. And what they refer to. So basically, if we specify in this way, the start refers to the 0. It means that from which part of the list we want to start. You can put the index there. Default value is 0. So there are like some default values in the same way as we saw with the range function. Then there is a stop. And yeah, we need like to specify from where to which part of the list we want to go. By default, stop is so the value is equal to the length of the list object. And also we can specify step for our slicing. And let's just take a look on these examples. I will again remove this part. And let's just discuss it a little bit. So here we have a list of the same elements that we saw before, and now we are using different type of the slicing. And the main idea here that you need like to remember, it's that, as I said, there are some default values. And for example, by default, if we put something like this, it means that we want to go from start to stop, and in this case stop equals to 3, but start by default equals to 0. And this statement is similar to specify the full statement, which would be this one. But usually we don't want to specify everything because it's like we are like lazy when we are programming. We want like to reduce amount of code that we are writing. And in Python there are like some shortcuts that allow us to do, for example, the same operations but in a shorter way. And basically this one is exactly as this full statement. Then also we can specify that, okay, I want like to go from start position, and in this case, so start position is 3, and go up to the stop, and by default stop is the length of the list. And because of that, we see that it's like 3, 10, 1. And the step by default is 1. In the same way as we saw that the step size was equal to 1 in range function. And also we can skip start, stop, and just specify the step. In this case, we just put double colon symbols, one after another one. And this means like from 0 to 10 to 2. I hope that it's like clear, guys. If you didn't get it, so then please say it. And yeah, so this is how it works. Basically, in first example, we are saying, okay, I want like to get slice from 0 to 3, and 3 not included. So because of that, we have like 0, I mean like in terms of the indexing, index 0, index 2, index 3. Oh, sorry, index 2, index, yeah, sorry guys, index 0, 1, 2, and 3 is not included in the same way as it was like in the range function. And because of that, we got like 10, 20, 30. And then, for example, in this case, we specified, okay, I want like to start from index 3, which this element, and go up to the end. And because of that, we get this slice. Like we just like, with a knife, we are like just cutting some pieces from our list. And in this case, in the last example, we have all elements with indexes that are even. For example, 0, 2, 4, 6, and so on. And we got our elements 10, 30, 50, 70, 90. So yeah, this is about slicing. And then you can try to play around. You can try to put negative step, for example, negative indexes for start and stop. Just play around and try to understand how to get different type of the slices. Yeah. And now I want to tell you about list assignments. because I think that sometimes it can be not very obvious in terms of the behavior that we got. So let's say that we have the following statement. And we have list assignment. So this is our program, and now I will press run the program. But before I do it, so this is a statement, and I just want like to understand if, especially like from the people who didn't work with Python before. So what do you think will be the answer? This is a question. Yeah, and try not to cheat. It's not about that I will like put some grade right away for the answer. It's more about just like to understand, do I see the picture in the correct way, that the behavior that we get, it's not like obvious. So here we have like two variables. The first variable is like numbers one, and we assign list from 10 to 100 to this variable. Then we create a new variable and we call it numbers of 2 is equal to numbers of 1. And then what we do, we are saying like, okay, I want like to reassign the first element in numbers 2 to 100. And the question is like, what do you think stores in the numbers 1 variable? So guys, please, and some options, especially people who didn't program in Python before.
So basically, do we want to know what is in the number one? The number one would not change, right? And if we want to know what would be stored in the list numbers of 2, so basically the same as numbers of 1, but the element with the index 0 would be 100.
Yeah. So this is what I am like referring to. So this is what was my first, like for example, assumption too. I would think that if I do something like that, and then if I change numbers too, my expectation was that numbers 1 will be the same. I didn't touch numbers 1. But in reality, so we will see that so here is a like a answer. So numbers 1, even we didn't like touch numbers 1 explicitly, right? Will be 100, 20, 30, and it's not very obvious why it happens. We will see, but let's just like verify that it works in this way. So this is our program, and we need to print numbers 1, and let's also print numbers 2 also. And so now we see that both of them are like equal, and it's like sometimes it can lead to the problems when we are writing programs. And why it happens? So here I have just like a visual explanation that I have in my mind. Basically, so this we can think about it that we have like our memory in computer, let's say RAM, right? And what we did, we basically we said that okay, this part of the memory in our computer, we will store there our list. Basically, we specified some range of the bytes. Let's think about this in this way. We specified some range of the bytes, and we're saying, okay, now these bytes, they will store values of our list. And then, in reality, when we create two variables, we don't create a new object inside of the memory. What we are doing, we're basically saying that, okay, we have one name, like one variable, and then we just assigning the object inside of the memory to this variable. And when we did, for example, numbers 2 is equal to numbers 1, what happened? We just took the link to this object from the first assignment, and we assigned the same link to the object in numbers 2. And now when we try to change numbers 2, at the same time we change numbers 1, or the other way around too. For example, if we do something with numbers 1, numbers 2 will be affected. And to avoid it, to do it like in a way that we probably kind of more more expected thing, there are like some options how to do it. But guys, do you have like some thoughts about why it's done in this way?
Memory optimization.
Yeah, that's right. So basically, for example, otherwise, if we would like always reassign variables and create a new objects in memory, we can get some problems where we are like creating over and over again new objects inside of the memory. And because of that, it's more, so it's like more efficient in terms of memory to just create like links to the objects, because in this case you need to think yourself like as a programmer that okay, you're like, okay, now I need like to create a new object copy of the previous one. And in this case we need like to remember that and do it ourselves. And this is an option how can we do it. Let's just put this example here. This one I will just remove again. Now what have changed? So numbers 1 the same, but we changed the way how we create or like how we assign the value to numbers 2. In this case we use splicing, and you can see that we like omitted all options or like values inside of the start stop step. That means that by default it will be start will be 0, stop will be the length of the our list, in our case it's 10, and the step will be 1. But slicing, it creates a new object inside of the memory. In this case, we will not get the link to the object which was like already created. We will create a new list in the memory, and we will assign this list to the variable numbers 2. And now if we change something inside of numbers 2, numbers 1 will not be affected. So here is an example. Now we have that numbers 1 the same as it was like in the beginning of our program, and now numbers 2 we changed just like the first value. And I hope that you got the idea. Yeah, and then for example, now if we want to check that 2 variables that we have, that they refer to the same object, in this case we can use id function. I'll create a new file. I'll call it like id function.py. Here is the code. The beginning is like the same in a way that we created numbers 2 just like by putting numbers 1 without any slicing. And as we saw, we will have like that the object which is like under hood the same. And now we can indeed check that the object under hood is the same by using the built-in function in Python which is called id. And this function provides us like the identifier for the object. And in this case we know that it's like supposed to be the same object. And then we try another way to create a numbers 2 variable. In this case we are using the slicing. And then we just check id of numbers 1 and numbers 2. And now we can see that in the first case, the identifiers, they are the same. You can double check, it's like a pretty long value, but the value are the same. In case of the second assignment, you can see so that the ending is like 48, but now when we used slicing, the ID ends with 92, which means like that the objects, they are different. And because of that, we are not affecting values. Okay, now we will switch to the, yeah guys, just let me know. Now it's clear, right? How it works, I hope. Yeah, cool, okay. But if it's not clear, then please, you should scream right away. You're like, okay, turning microphone on and you're like screaming, and we are trying to figure it out. Now, the thing that I really like in terms of the data structures in Python, that by default they provide some methods that we can use. And let's see first example. I'll create a new file for this thing. And here we have, so we created a variable and assigned the list with the values which we think represent the stress level. It's like 0, 0, 10, 20, 100, 0, 0. And let's say that we want now to add new value to the list. And to do that, we can use some built-in functionality to the lists inside of the Python. Here how it works. We need like to put the variable name, and we are saying, okay, I want to append a new element to the list. So the idea is what was happening. So the stress level was low, then it went up, then it went low, and then it again went up. I don't know what happened, but something happened. And we will just print the result after we appended a new element. So you can see that we added a new value to the list. And basically what we did, we used some default functionality that Python has for different type of the objects. In this case, append method is specific to lists. And you can see how we did it. We put the dot, and then we used the name of the method. We will see like all names, not all names, but all methods that are like already implemented in Python in a minute. This is just an example. Also, I just want to show that you can do it in the same way as I showed it before. So you can see I got some hints. I can put append right after the list. And you can see, so what's happened, in reality, so we appended the value, but what happened that in this case, we got back the result of the method. And by default, method works in place. So we changed something inside of the list, but we didn't get as a return result of the list. And it really depends on the method that we are using. So for example, if we use some other method, I don't know if I have the example. So yeah, this is a link to all methods that we see in the list. You can see, so we used append, there are like clear, copy, count, all of them. And if you go to different to the explanation, you can see that so there is like a behavior of the method. Let's now try to use pop. Pop means so we want to remove the element in case if we don't specify any argument, we want like to remove the last element of the list. So let's just use it. And you can see, so in this case, what happened, that we removed the element, but also we returned it back right away. To make it clear, let's create numbers, and let's assign 0, 1, 2. And now I'll put numbers here. So we returned back 2 again, but now if we print numbers, we see that we excluded the last element. And this is just the idea about how methods works, that some of them performs operations in place. So we change the object in place, but we don't return anything back as a result of the operation. But some of them like do something, for example, in place, and also could return something back. There are some methods which, for example, don't do anything with object in place, they don't modify it, but can return us back some, for example, some summary statistic or something like that. Yeah, here are like more examples about we can add not just one element, but for example, list of the elements at once. In this case, we have this example. Here we have like a stress level again, and now we want like to extend. Basically, we want to add multiple values at once. And here we have extend, and we will add 90, 80, 70, and then we will extend it. Yep. And so here, after that, we pop the element. As we saw before, we will exclude the last element, which is 70. And then also we can sort list in place. So this is how it looks like. After extend, we added 90, 80, 70, right? After pop, we dropped the last element, which was like 70. And after sort, now our list, we sorted it in place and in ascending order, right? So 0, 0, and then we have values going up. Yeah. Here probably I just want like to show you that there is a function in Python, built-in function, that if you want like to sort values and return it as a some like object, you can use function sorted. And this is again in the same way like the difference as we saw it before. The sort will return us nothing as a result, but it will change object in place. But if we use sorted, then we will also get the value. So for example, print 0 minus 10, 10, something like that. If we do sort, you see that we got none, like as a nothing in this case. But sometimes we want like to sort it and get back result, but don't change the underlying object itself. So in this case, you can use not the method, but the function. There is a built-in function which is called sorted. And now you can see that we sort the values. I just want like to make it like super clear. I'll create a list of vals. Let's just remove all this part and like just focus on this one. And our list is this one. So this is our values. And now we want to sort them and print them back. And then let's check what is variable vals is. So you can see that we sorted them and we just like sorted and get the result back, but the object vals itself, we didn't change it. So this is the difference between like a method sort and function sorted that you can use in your programs quite often. Yeah, and here is an example about how can we delete the element of the list. You can use the del statement. And in this case, how it works, so you basically are saying that, okay, if something was like in the memory, I want just like to kind of free the space, saying like to say that this memory now doesn't, so it isn't refer to, it doesn't refer to the some Python object. So you can check it that the example will be like we deleted the value with index 2, which is 10, and now after that our list shorter. Okay, there are like also some operations with lists that we can use. Some way it's similar to the operations with the strings that we saw. We can, for example, repeat the value by using the multiplication. Also, we can use plus operator to concatenate lists. So here is an example. At first, we created a list of 10 values, which filled with zeros. And then we used plus 10 multiplied by 3. In this case, so we created a list of 3 elements and they are 10. And then we concatenate it. Okay? And now, so yeah, so basically we saw before that, okay, there is a range function, there is a slicing, and so by default they take length of the list. But how can we manually calculate the length of the list? And Python provides the function which called len, short of the length. And it allows us to calculate the length of the object. So this is a example. This one I will show. We have our numbers, and then we want like to get the length of the list, how many objects inside of the numbers. And this is 10. And now after that we can use this with we can use it with loops. So first example is like just like how we can use for loop and fill elements of our list. So here you can see we created the empty list, and then we are saying, okay, now I just want like to calculate, like to add elements to the list in the loop. So guys, question to you, like to make it more interactive. Why would we use for filling the lists? Your ideas. For example, why it's better than the previous option that we had a couple minutes ago, where we specify them ourselves. Any ideas? No? So I'll try to choose people myself. So Ekaterina Marenina, could you any ideas?
Automatization. I don't know.
Yeah, right. So
Just
usually
faster.
right. Yeah. Because imagine that you have like one you need like to put 1 million of elements inside of the list. And it's like it can be like super easy, super simple. For example, from 0 to, or like from 1 to 1 million, and you want like to put them, right? And then I don't want to type all of this. So you know, like it depends on the person, definitely. But usually we don't want to do something like that. We want like just like to simplify it, and then yeah, so we can use for loop saying like, okay, from 1 to 1 million, Python, add it to the list. Yeah, cool. Let's just run it, and we can see. So in this case, we specified values from 0 to 9, and now you can like play around. You can say, okay, I want like more elements. Wait, you see that it's like freezed for a moment, but now we have like this like huge output that we added all these elements to our list. And now about the length, that sometimes we want like to go through the list that we have through each element and perform some action. And in this case, now we can use we can combine range with the length function. And what we are doing here, so we are like saying, okay, I want like to get all indexes from 0 to length of the numbers, and then we want like to print the square of the value. Super simple. So here we had like our values from 0 to 9, and then we calculated squares of these values. Also, I want like to show you. I'm not sure that I showed it to you before. It's about how can we, for example, modify a little bit the print function behavior. So in this case, you see that every single element that we printed on its own line, on a new line. Sometimes you want like to make it shorter, and in this case you can say like, okay, I want like to split values not by the new line operator, but by for the white space. And in this case you can pass after the comma the end argument to the print function. You just need like to remember it and then run it, and you can see, so we got our elements separated by the white space. One thing that you need to remember, that this white space also was added here instead of the new line symbol. And in this case, so for example, if I print now what's up, something like that, you see that it goes not on the new line, but with the previous element. So you need like to remember that you can, for example, just add one empty print after your for loop with this modification, and then it works again in a more human readable way. Okay, so I will remove these parts. And yeah, and now you can even, for example, reassign values here. So let's say the numbers of I equals to numbers I, but not squared. We want like to exponentiate it to power of 3. And then we want to print numbers. So you can see that we calculated squares and printed them right away, but also we changed our values and we calculated like what are like the results of if we exponentiate to power of 3, 0, 1, 8, and so on. Yeah, so this is an example, basically the same. Yeah, also what is interesting that for is very powerful thing in Python. In general, we can, for example, omit this like indexing, and if you just want like to go through all elements in your list, you can use for element in numbers. This name can be any type of the name which is allowed by Python naming convention. So it can be X, I, whatever. In this case, I called it lm for element. Let's just add it. I'll remove these parts, guys. Just like to make it simple. So here we have our numbers. We added like 0, 1, 2 up to 9. And then also here we just like we go for element and numbers, print element. And you can see so the difference that we didn't use indexing in this case. So, and we got like 0, 1, 2, and here we again used AND option. But what is interesting in this case, if we use this syntax for element in numbers or like for X in numbers, let's just change it to make it clear that you can use different names. Works in the same way. But now, for example, we have our numbers from 0 to 4. And let's say that I want like to change our values. And I'm like, okay, I don't know how it works. I suppose that if I do element, reassign the element by the element is equal to element plus 5, it will give me results. So this is my expectation, that after that, values will be 5, 6, 7, and so on. Okay. But you can see that we didn't modify original numbers list here. And why it's happening when we do something like that, you can think about it that we create the copy and we store the copy inside of the element. We don't like work with the value in place. There are some cases when you can modify in general the value. Maybe we will see it, maybe we will not. But if you're like very, how to say it, just trying to find the words. If you're like a true researcher, right, then you should research. You need like to go to the Google, to the, I don't know, to the OpenAI ChatGPT, and you're like, okay, it works here, but can I modify it in some particular cases and get like problems? And you will probably find out that, yeah, there are some. Yeah, also today I want like to show you list comprehensions, and probably after that I want like just to switch briefly and talk a little bit about the first homework assignment that we saw like on Monday or maybe on Tuesday, and just like explain about Stepec system briefly. And you can go over the tuple data type. It's pretty simple in a way that it's similar to the list, but there are like some definitely difference that you need to know. So I want to show you list comprehension, and in my mind it's like super cool tool that you can use and simplify your code. But again, sometimes you can like simplify it too much that it will be even more complex than it was before. I want to show you the example with I'll call it list comprehension.py. This is what we saw. So we can create an empty list, fill it with values. we used here 4 lines. Oh, okay, 3. We don't count print. But in reality, we can do it in 1 line. And this is a difference. So let's just run it. Results are the same. And this one is called list comprehension. So how it works, or how it looks like, that we somehow used the for loop. We wrapped it inside of the square brackets and did it in 1 line. How it looks like. So first thing in the list comprehension, we specify the value that we want to add to the list. In our case, it's I. And then we are like specifying the for statement through what kind of elements we want to go over. And in this case, it's exactly as we saw it here. So for E in range of 10. And then we print numbers. Because of that, we got the same result. Here, let's just like play around with this statement a little bit. So I hope that you got it. I'll wait like 10 seconds that you can just like observe as a, I don't know, as in some like cultures, they're like, okay, just like silently observing. And now let's switch. I want modify it, for example, and say that I want like I plus 5. And you see that we go through the 0, 1, 2, 3, 4 up to 9. But as a value, we add 5 for each element. You can play around, use some different things. So for example, you can multiply everything by 2 or like exponentiate everything. So it's pretty handy. Now you can also add if statement inside of the list comprehension. So this will be our second example. This one I'll just comment. And here is our example. So we are saying, okay, I want like to get as a value inside of my list is like I multiplied by 10. As a loop, it's like for I in range of 10. And then we can add the condition. So we are saying, okay, if I multiplied by 10 is greater or equal than 50, this is our condition. And basically, if it's true, if the condition is true, we will add element to the list. If it's not, we will not. So let's just run it, and you can see that we got like 50, 60, 70, 80, 90. And this is a very nice way to, for example, filter out something from your values. Let's say that you have, I will switch a little bit and try to tell you about the system biology and bioinformatics. Let's imagine that we have list, and list stores gene expression values, right? And you're like, okay, I want to filter out those genes which expression are like higher than, I don't know, 10 or something like that. And you're like, okay, this is how I can do it. Yep. What is this one? This one is like a little bit tricky, that you can specify multiple for statements inside of the list comprehension. And here, sometimes it can be like people like going crazy. They're like, okay, I want list comprehension in some case where it's not, I mean, like, it doesn't worth it to put it in this way. For example, if you have like some like huge statements, usually it's better to split it into smaller, and then other people can easily read them. Here I just wanted to show you that we will create all possible pairs as a Cartesian product for values. So here how it looks like. We convert I to string, and I goes from 0 to 2 included. 0, 1, 2. And for J we do like 0, 1, 2, 3. And this is like a result. Yeah, so basically we created all possible pairs, 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, 1, and so on. And we converted them to string. So basically here we converted to string, and because of that, after we converted, we can use plus for strings to get the concatenation of our strings. So that's it about list comprehension. Yep. Probably here I don't show you, but also what I like to do in my own programs sometimes, not always. So I'll just try to come up with some example, and I hope that I will not fail. So let's say that we have values. And I'll do it very simple. So, and I'll even show you some trick that you can also, I believe that you can try to learn some things yourself. So I'm like showing something, but in my mind, really people learn something if they're like trying to do everything themselves. They're like, okay, how to do this, that, you're like searching, reading, and then you're like, oh, I got new skills, and I even didn't see it during the lesson. And you're like, wow, I'm like much better now if I compare myself to the yesterday version of me. So let's say that we want like to create a list. I will use this statement, and you can then just try to read what does it mean. So this is my values. And now what I wanted really to show you, not this part, but that we can use also ternary operator inside of our list comprehension. So I am like making so many typos. You know, it's like early morning, and I'm like sometimes my brain is not working like with the full potential. Okay, so now I just want to use ternary if-else statement that we saw in the beginning of today's lesson. And let's say that I want like just to check my number is even or odd. And I'll put true if v. So, and you can see here I used not the indexing, but another type of that we can go through the iterable object. So list is an iterable object. We can go through these values by using for element in values or like for v in vals. The names are like pretty arbitrary. And I want to check that if this thing is 0, then it's true. Otherwise, it's false. And now let's just execute it. And I am like, didn't print statement. So here we got it. Basically, for each value we now have like true, false, and how can we call it, or how can we then see it in some other cases? We can call it that we can we can call it that we created the mask. Basically, masker is saying if something is like covered by our mask or not, and we can then filter out some things. Or let's say that you now want to calculate how many even numbers inside of your program. And then you can do something like that. So let's say that we have n, and you can go for value now in new vals and say like n plus equal v. So it's just improvisation, I don't know. And now we got that there are like 5 even values in our list, just like to show you some examples. In reality, again, if you're like, you know, like if you're like trying to learn some things yourself, you can find that there are like some ways to do this type of operation even like faster and more readable. Because by default, Python has function, built-in function, which is called sum. And what it does, it like takes the, for example, list and sum up all elements inside of it. And I want like to use it sum of new vals. And now if I execute it, I get the same result, but faster. So, okay, guys, that's it for today, but I just want to show you briefly about stepping system. Just like to explain. I hope that you already signed up and yeah, give me a second. I'm just trying to log in to Stepic. So yeah, there is the first lesson, right? I hope that you see it. Yeah, and how it works. So basically there is a program. Usually, sometimes you can have input, sometimes you don't have it. And then this is a like sample output. What does it mean? So in this case, we don't have input, and that means that we can avoid using, for example, input of something. We don't need to read anything. In this particular case, it asks us to print something, to perform some operations and print. In this case, I believe it's like print hello world. We just need like to do exactly this one. Let's just check. Yeah, nice. I did it. There was like a high chance that I will fail. So, and I want just like to show you this example. In this case, we have like a sample input. This one is much harder now. And yeah, let's try to do it. So I want like to get it like as a line 1 is input. So basically this is we see that it's a first line inside of the input. And we know that input usually takes the line and waits until the new line symbol arrives, which is the enter button when we print. And then input, and okay, I finished. And I will do it in this case by using this one. And then we want like to concatenate them. And if I remember correctly, we can do something like that. Let's just check. Boom, and we did it again. So yeah, and this is basically the idea. Sometimes there is an input. I will not try to solve this one because I can, you know, more tasks you're trying to solve in public, more chances that you will fail up. And then like students are, he doesn't know how to solve tasks, and he's like asking us like to do something. And yeah, so respect is going down. So I will not do it anymore in public. But this is just as an example that usually there is an input, then we want to print something. There will be some cases, and please check it. I'm not sure that it's like in this homework, but then at some moment, then yeah. So for example, here, right, there is a node. Your program should not print anything, and if in case if you try to print, it will break and you will not pass. Yeah, let's just try to. So I'm trying just like to solve last thing. And it's saying like you have two variables x and y, write a program that swaps the values of two variables. And there is a comment, please usually read them. They appear not randomly. It's just like to explain something. Yeah, so here in this case, you are like, the variables x and y have already been declared previously. What does it mean? That in reality, they are somewhere there in the upper in the code. And we need like to swap x and y. And probably we can do something like that. Yes, let's just check. Yep, so that's it. I'm not gonna solve any tasks anymore. Yeah, Ilya, you have a question?
Yes, is there any limit of tries on our home tasks?
No. So basically, I'm not checking this part. You can try as many times as you want. You can try different options. So usually some people sometimes doing in the way that they're like, okay, I have the idea how to solve the task. You solved it. And then you're like, okay, can I optimize it? Can I make it like better? Also, you can really use the help topic inside of the Telegram in case if you're faced with some issues. But please, guys, don't share the solution right away. I mean, it's more about like that you're like, okay, you can, for example, briefly describe how you did something and then ask people for their questions. And I know that, yeah, nowadays you can easily do the same things with the ChatGPT. And in this case, also just try to use prompting in the way that it's not just like provide you answer right away without any explanation, but maybe that it gives you some hints how to solve it and try to really get knowledges and skills yourself. So that's it for today, guys. Yeah, and this is about homework, so please try to be on track with deadlines, and then everything will be fine. In case if you want already to start working on the mini projects, just text me. And in case if you, for example, if you're like super new to Python and I gave you like topic that you're like thinking this super hard, you can like, again, you can use help section, help topic inside of the Telegram, or you can text me, and in case if I have time, I'll definitely try to help you. So yeah, that's it, guys, for today. Yeah. So no questions, right?